Hi calculus students, we're here in section 6.7, the fundamental theorem of calculus and definite integrals. Looks like we have a blank graph here, so I'm going to go ahead and graph something here. Let's go up and down. Okay, and then maybe something like that. Okay, so we have our function, and this actually is our function f prime in the graph. The graph of f prime is shown in the figure to the left, and we know f of 0 equals 12. And we want to figure out which of the following values, 20, 24, 36, or 43, could be the value of f of 6. So what we want to recall is that f of b minus f of a is equal to the integral value from a to b of f prime. And so we have a value, looks like of 0 and 6. So we're going to say f of 6 minus f of 0, which we know is 12. And that should equal the integral value from 0 to 6 of f prime. And then we could isolate f of 6 and get f of 6 is, we know it's 12 plus the integral value from 0 to 6 of f prime. Now we need to somehow estimate what the integral value of f prime is, but we're not going to count boxes. We know that it's definitely positive, so the answer has to be more than 12, which doesn't help us. But we want to recall that there's a property that the min f, the minimum function value over the interval of 0 to 6, so min f times 6, the integral value will be greater than or equal to that for sure. Okay, it's a property called the min-max inequality property. And so we have the following statement, and also the max f times the width b minus a, which we know is 6. So we know the integral value is kind of squeezed in between here. And if you look at our function f prime, the maximum is at a height of 5. And my minimum of my function is at 2. So we have a min f times 6 to be 12. And a max, which is 5 times 6, which is 30. So we know our integral value is going to fall between 12 and 30. Okay, now f of 6 is clearly up here as 12 plus a number. So 12 plus a minimum of 12. So we know the answer has to be greater than or equal to 24. So it can't be 20. And we are missing quite a bit of the integral. So we're still missing this part here and this part here. So we know for sure it also cannot be 24. That's the area of that small rectangle plus 12. What we also need to decide here is, what about that 36 and that 43? Well, if you add 30 to 12, the most that our f of 6 could be would be 42. And I guess that throws out the 43. So we only have one answer that we're going to go with, which is 36. Now, it doesn't mean that the value of f of 6 is 36. All we know is that it's what our best answer is for this problem.